Here are the Physics to Go questions with some of their solutions. So that way you can see if you got your questions right or you got them wrong, so you're fully prepared for the exit ticket. All right, so we're drawing a top view and a side view of this roller coaster. Starting from the platform, it's going to go up hill number 1 and make its first big drop, the big fun one, and then it's going to climb hill number 2. That's half the height of hill number 1. True. The car then goes along the back curve, rises over hill 3, and swings into a horizontal circle. So from the side, the horizontal circle is represented like this. The coaster then comes out of the circle onto a level plane, then brakes are applied, and the roller coaster comes to a stop. From the top, this is what it looks like. Now you can see the circle a little bit better because it's horizontal. So horizontal means that it's like this. So if you look at it from above, it's going to look like a circle. There's number 3. Number 2, identify where the biggest thrill is and why. So the biggest thrill is probably going to be in the clothoid loop. Clothoid loop, that's the balloon loop. This is where the riders are experiencing an acceleration due to a change in the speed with respect to time, and acceleration due to a change in direction. They're also upside down for a few moments. 3A, Earth makes a complete revolution once every 24 hours. Not exactly, but okay. La Paz, Bolivia is close to the equator and travels a large circumference in 24 hours. Oslo is close to the Arctic Circle and travels a smaller circumference. Which city has the greater speed? Well, La Paz will have the greater speed because it's covering more of a distance in the same amount of time. And the distance is going to be greater at the equator, right? The big fat Earth right around the center. Norway goes a smaller distance in the same amount of time, so it has a slower speed. The circumference of Earth's equator is about 40,000 kilometers. It requires 1 day or 24 hours to complete one revolution. Calculate the speed you are traveling on Earth if you are at the equator. So remember, the speed is distance over time. We have distance and we have time. It's not a vector, so it's not velocity. We're given the distance to be 40,000 kilometers and the time is 24 hours, so the speed is about 1,700 kilometers per hour. Whew. Why do you not get a big thrill at going such a high speed? Thrills are produced by changes in velocity. As Earth rotates, the speed of the place on the surface does not change significantly. The direction of the velocity does change because the location is in circular motion, but the resulting acceleration is very small. And we're going to get into that a different time. Roller coaster rider traveling in a straight line changes from the speed of 4 meters per second to 16 meters per second in 3 seconds. Calculate the acceleration of the ride. Remember, acceleration is the change in velocity. So we have a final speed, final velocity, and the initial. So it's final minus initial divided by time to get 4 seconds. Identify the following situation as an example of either distance, displacement, speed, velocity, or acceleration. A car traveling at 50 kilometers per hour is a speed. Student riding a bike at 4 meters per second towards home is a velocity. We have a magnitude and direction. A roller coaster ride whipping around a left turn at 5 meters per second is acceleration. The direction is changing. So that means there's a change in velocity. A roller coaster car is dragged up a hill 12 meters tall, traveling at 3 meters per second. This is displacement because we have a direction, which is up. A train ride takes you 150 kilometers northwest. Displacement, magnitude, and direction are present. Next up, a lab car is 10 centimeters long. It travels through a velocimeter in 2 seconds. Calculate the cart's speed. Distance over time, 10 centimeters every 2 seconds is 5 centimeters per second. A second lab cart is 5 centimeters long. If it were traveling at the same speed as the cart in question 6, what would the velocimeter record as the elapsed time? Okay, so it's half the distance, and the speed is the same. And we're looking for time. It's going to take 1 second. Half the distance, speed is the same. Your vehicle accelerates from 0 to 25 meters per second in about 10 seconds while traveling down a straight street. What is the acceleration? Acceleration is change in velocity over change in time. Our change in velocity, we went from 25 meters per second, or we went from 0 to 25 meters per second, so the change was 25 meters per second, and the time is 10 seconds. So acceleration is 25 divided by 10, 2.5 meters per second squared. That squared just means every second that goes by, your velocity is changing by that much. Meters per second per second. As noted in the physics talk, physicists often introduce terms and distinctions that seem to make simple things more complicated. As you were told, these distinctions can make very difficult things much easier to explain and understand. Give an example outside of physics where you make a distinction for simple things so that complicated things will be easier to understand. You've been doing this your whole life, your entire life. You've had teacher after teacher taking something really difficult and making it easier for you. Are there shortcuts that you found in math? That's the kind of thing. And finally, if you were designing a roller coaster for young preschool children, 2 changes you would make to the Terminator Express roller coaster. And why would you make these changes? Draw the top and side view of the roller coaster with these additional changes. Mostly you just want to slow things down, smaller heights, gentle curves, small changes in acceleration, so that way it's not too scary for preschool-aged children. And then your drawing should show those. That's it. I hope you're ready.